Alright, in this video we'll see how to solve this problem where we need to find out the price of a bond that pays semi-annual coupon payments. Alright, so what you have here is a bond that has a coupon rate of 9%, 5 years maturity and par value of $1,000. Now usually the maturity of bonds is much longer than 5 years. It could be like 10 years, 15 years or more. But let's do it with 5 years because it makes the explanation much easier. And if you can do it for 5 years, you can do it for 30 years or whatever number. Alright, and it pays semi-annual coupon payments. That means that the bond issuing company will pay you coupons twice in a year, each after 6 months. And the annual market interest rate is 7%. Now what is the price? Now what you have here, we have a par value of $1,000, coupon rate of 9% and the maturity of 5 years. What this tells us is that the coupon payments of this bond will be 9% of $1,000 because this 9% is the coupon rate, $1,000 is the par value, so $90 will be the coupon payments in each period, right? So in each year we'll receive $90 annually. But it is also mentioned that it pays semi-annual coupon payments. That means the issuing company will pay $45 after 6 months, and again after another 6 months they will pay $45 more. That makes it 2 payments in a year. So this is what is shown here. So split this into 45 and 45. Alright, finally this C represents the frequency of compounding. In our case, how many times we get coupon payments? 2 times, right? So that's why C is 2. If we received coupon payments 12 times in a year, then C would have been 12, and so on. Alright, now this is really important because we will be adjusting our interest rate and also adjust our periods of payments based on this C, because what you have here, we have a coupon, we have a interest rate of 7%, but this 7% is on annual basis, right? But our coupon payments is based on semi-annual basis. Again, the period 5 years, this is on annual basis, we need to convert it to semi-annual basis. Now to do this, when you adjust the interest rate, you divide it by C, or the frequency of compounding, and when you adjust the number of periods, you multiply it by C. So that gives us 3.5% semi-annual interest rate and 10 periods, right? Now we are all set to solve this problem, but let's make this a little bit more clear. Alright, so what you have here, interest rate 3.5%, number of periods 10 periods, par value $1,000, and coupon payments of $45. Now the value of the price of this bond is the present value of all the future cash inflows that you'll receive for holding on to this bond. Now what are the cash inflows? We can make 2 categories out of these cash flows. One is for this one single payment that you receive after 5 years, so present value of this $1,000 here, and another one is this series of equal payments of $45 that will take place over the next 5 years, and this looks like an annuity, right? So we need to find out the present value of an annuity and the present value of a single amount. Now let's do this one first. We know that the present value of an annuity has this formula. Let's write it first. Alright, what you have here, this payment is the equal amounts of payments of the annuity. In our case, it is $45, right? We receive 10 payments of $45. So this is 45, and this is the interest rate, which is 3.5%, and this is actually T. Let's make it a bit clear. So our T is the number of periods, which is 10. Now let's put the numbers into the formula. So we have 45 multiplied by 1 minus 1 by 1 plus 0.035, that is 3.5%, to the power 10 divided by 0.035. Now if you solve this equation, the result you'll get is 374.25. Alright, so the present value of this annuity is this. So let's put it here, 374.25. Now clear this again. Alright, now let's calculate the present value of this $1,000 that we'll receive after 5 years. The present value would be the future value, that is the $1,000, divided by 1 plus I to the power t. Now plug in the numbers. Interest rate is 3.5%, and the t, or the period, is 10 periods. Now the result of this is 708.92. So add this with the present value of the annuity, and the result is alright. So this is the present value of all the future cash flows that you'll receive for holding on to this bond, and this is also the value or the price that the bond should have. Now the market price could be different from this price. Actually it should be different, it should not be exactly like this, but ideally this should be the price of the bond. Alright, that is all for this video. See you in the next one.